Hello YouTube, today we're going to be taking a look at a circuit and analyzing it using three different approaches, just to kind of give you an idea of how circuits can be analyzed in many different ways. This one's kind of cool. It asks us to find the value of the current source in order to force the current at the center there across that resistor of 6 kiloohms to be 0. So one approach we can do is by KCL and KVL. We can do the loop rule here, and by showing where the currents are, so we know the current source has to sum at that point and the original current there, which should be 0 from that given information, so we have to force it to be 0. So we know that by KCL that IS, the current source, has to be equal to I1 in this case, as I labeled, so that the current sums to be 0. But by the loop rule and using Kirchhoff's voltage loop rule or law, we go say, okay, here's the loop, so we're going to go from the battery from 9 volts, we're going to subtract the current from this the 6 kilo ohm resistor through there. That would be, since V is equal to IR, that's R, and I would simply be the I1 as we labeled minus the current source, because that has to be there. And then you subtract the current or the voltage through the 3 kilo ohm resistors, as that we labeled as I1 from the loop there. So by that equation, we know that the voltage has to be 0 around the loop. So we solve for I1, and we know that I1 actually equals IS. So when you simplify, you just get 9 volts over 3 kilo ohms, and then you get 3 milliamps as a result. So the source has to be 3 milliamps. Another approach you can do is kind of similar. You use the node rule, and you look at this node I just labeled A, and you know the current flowing through all those areas. So for KCL at A, we say, okay, current coming in is negative, so the current going through coming at A is negative S, or negative IS, which is the current source, and then the current leaving is positive, so we have the voltage at A over 6, because I is equal to V over R, and we're going to call that VA, the voltage at A over 6 kilo ohms, which is coming down there, and then we have to look at the 3 kilo ohms, or excuse me, we have to look at, the 3 kilo ohms, but we also have the battery here too that's providing current, so we have to subtract the voltage from the node and subtract it from the battery. And since the battery is in the positive direction there, it's minus and negative, given the sign convention there, over the 3 kilo ohms, because it has to go through that resistor, because I is equal to V over R, and that should equal 0. And then you can simplify by pulling out a VA and getting the fractions, bringing IS to the other side, and the negative 9/3, which is simply 3. And then divide by the fractions, simplify, and you should also notice that I is equal to VA over 6 must be 0, because we're saying this current has to be 0. So if that's true, if we're making that happen, we show that mathematically only when VA is 0. So therefore, VA has to be 0. So then the current source has to be 3 milliamps. One final approach is superposition. It takes a little longer, but still works. So let's look at on the right here. We're going to leave the battery, and by superposition we remove all current sources except for one, so we're keeping the battery. Notice how I flipped the signs, by the way, just for convenience. So it's not negative 9 volts anymore, it's positive 9, but notice how I switched the positive and negative sign. So we're going to solve this for I2, we'll say, because we have to do the other circuit as well. And you just notice that they're in series, so our equivalent is 9, 6 and 3 is 9, and you just solve for the current through that resistor, which is V over R, and the voltage is 9, and our equivalent is 9. So you get 1 milliamp. Now if you look at that other circuit, you'd have to draw, or it's negative, because the current, I should have drawn it, but the current is flowing clockwise, so the direction that I2 is pointing is opposing that clockwise direction, so that means the sign has to be negative. So then we look at the second circuit drawn here, and we are solving for the same thing again. I should have called it I1 instead of I2. But anyway, we know that the current leaving, since these are in parallel, and we already know what I2 is supposed to be, negative 1 milliamps, we can just say it's the total current source minus the 1 milliamp going through. So you can solve for that, and show that these two are in parallel, 6 and 3, and that makes 2 for our equivalent, and then you can use KVL and do a loop, so you get negative 6 volts plus 3 times the quantity Is minus 1 equals 0. Simplify, and you'd find that Is is equal to 3 milliamps. So pretty cool, right? You got to see 3 approaches in solving this problem. Pick whichever one works for you, or that can be the quickest depending on what you want to go for. If you want to practice superposition or do some KVL, KCL, it's kind of like figuring out which approach would be the best and the quickest for analyzing a circuit. So I'll leave that decision up to you. I hope you enjoyed this video.